Good morning students. What are seen in the previous class now? That is meter bridge and potentiometer and working of meter bridge and working of the potentiometer. That all are learned in the previous session. Okay. In the today's session we will discuss about that heating effect of current. What's the meaning that heating effect of current? The current it will be passing through one circuit. The circuit having resistors. Resistor definitely drops some voltage. Okay. So it will be reduce the speed of the current. It will be drop some voltage. That the voltage it will be dissipated in the form of heat. That is heating effect of current. So one current will be passing in one circuit. 50% of energy only it will be the working of this circuit. Other energy it will be dissipated in the form of heat. That is heating effect of current. So I will explain that the heating effect of current according to the rule of in terms of the rule of Joule's law. What is the meaning that Joule's law? Joule is explain one law. It will be giving one law to explain the heating effect of current. Okay. Joule it will be tells the one current it will be applying in a circuit. The heat energy will be generated. Some work it will be done. That the work done it will be equal to work done W is equal to V into Q. So V into Q means voltage applying. The potential difference is charge it will be applied, some potential difference it will be dropped across a resistor. So the work done it will be equal to voltage into charge. So work done it will be equal to voltage into charge is I into T, it's the product of current and time. So W is equal to V into IT. Okay. So work done is equal to V into IT. So according to the Ohm's law, V is equal to IR. So substitute V IR. So W is equal to IR into I into T. So work done it will be stored as a heating energy H. So heat energy H is equal to I square R. This is Joule's law. How will you derive the Joule's law? Work done W is equal to product of voltage and potential difference V into Q. So work done W is equal to substitute the Q value I into T. V is equal to IR. So IR into T. IR into IT. So I square RT. Work done will be stored as a heat energy. So heat energy H is equal to I square IT. This is the Joule's law. How will you define the Joule's law? The amount of heat is developed per unit length of the circuit. It will be equal to square of the current, product of square of current and resistance and time. So heat energy will be directly proportional to the square of the current, directly proportional to the resistance, and heat energy will be directly proportional to the time. And then another way I tell that Joule's law. Heat energy will be completely dependent upon the current, resistance and time. So this is the Joule's law. How will you define the Joule's law? Joule's law is defined as amount of heat is developed in a circuit. It will be equal to the product of square of the current and resistance and time. This is the Joule's law. What are the applications of Joule's law? What's the way it will be applied in the various daily life activities? So I explain one by one. Okay, first electric heaters. So 4 application is there. One is electric heaters. Electric heaters. Give some example for electric heaters. Iron box, geyser, toaster, induction, and microwave oven. That all are the electric heaters. So electric heaters will be works on the principle of Joule's law. How? Electric heaters having nichrome. So iron box in center is one rod is there. That is nichrome. Nichrome is the alloy of nickel and chromium. Okay. So nichrome it will be having is the alloy of nickel and chromium. Okay. Nickel and chromium. The nichrome having high melting point and then high specific resistance. So nichrome it will be always having high melting point. High melting point. So easily it's not to be melted. And then high specific resistance. High specific resistance. Okay. So high melting point and high specific resistance and cannot be oxidized easily. What's the meaning that cannot be oxidized? You have to continuously applying the current, the rod it will be continuously heated, not to be vaporized easily. That is called oxidized easily. Okay. Easier vaporize aayirada, not to be oxidized easily. So one is electric heater. So electric heaters is always having nichrome. Nichrome is having high specific resistance and a high melting point and then cannot be easily oxidized. So nichrome it will be used to electric heaters. You have to apply current on the heaters, the nichrome to be heated and then it will be worked. Okay. So that is the electric heater. And second one is electric fuse. What is fuse, ma? Fuse it will be used in all our home. So in our home electricity board are having one fuse. That the fuse is nothing but just one ceramic rod having centered one ring, one string is there. Suppose if the excess amount of current it will be falling to the circuit, that the wire it will be break down, and then it will be not to be supply the current to the another other electronic appliances. Fuse la central or line irukum, string irukum, neenga current apply பண்ணனே suppose excess of current adha flow ஆகுதுன்னு வெச்சுக்கோங்க, அந்த சென்டர்ல இருக்கக்கூடிய string break ஆகி discontinuity ஏற்படுத்திடும். ஸோ எலக்ட்ரிக் சர்க்யூட்லேருந்து கரண்ட் வந்து மற்ற அப்ளையன்ஸுக்கு சப்ளை ஆகாது. ஸோ மற்ற அப்ளையன்ஸ் எதுவுமே அஃபெக்ட் ஆகாது. ஸோ தட் இஸ் த important use of electric fuse. Nowadays we will use the electric fuse in the form of MCB. Electric fuse, one disadvantages is there. Suppose one time the excessive current will be fall, the current the wire will be broken. That time you must want to be replace that string. Suppose we made another one form of fuse, so it will be very useful, that is MCB. MCB is miniature circuit breaker. Miniature circuit breaker, it will be used in various industries and schools. Okay, where miniature circuit breaker having one knob is there. Suppose excess amount of current it will be fall, the knob will be fell down. The trip item சொல்லுவாங்க கேள்விப்பட்டிருக்கீங்களா, tripper it will be moving down. So that the time the current does not falling to the other appliances. So this is the another form of fuse, that is MCB, miniature circuit breaker. So you have to find out the faulty in the circuit, you have to overcome that, then again you have to move up to the tripper, and also that the MCB will be working, not to be replaced. Fuse வந்து நீங்கள் ரீப்ளேஸ் பண்ணி ஆகணும், MCBயை ரீப்ளேஸ் பண்ணணும் அவசியம் இல்லை. பிகாஸ் ஒன் டைம் நீங்கள் அந்த ஃபால்ட்டியை கரெக்ட் பண்ணிட்டீங்க அப்படின்னா அகைன் அந்த MCB ஒர்க் ஆகும். ஓகே, ஸோ ஃபியூஸ் it will be working in the form of heating effect of current. One is electric fuse. Electric fuse will be having always alloy of lead and tin. It will be having low melting point. Why? Low melting point means little bit of heat it will be created excessively, immediately the wire will be broken. So the discontinuity of connection is to be made by using the fuse. Fuse oda ஒரே ஒரு யூஸ் என்னன்னா எக்ஸஸா கரண்ட் ஃபால் ஆச்சு அப்படின்னா அதை உடனே பிரேக் பண்ணிடும். ஸோ பிரேக் ஆனதுனால மற்ற அப்ளையன்ஸுக்கு அது வந்து கேரி அவுட் ஆகாது இந்த கரண்ட்டுடைய லெவல். ஓகே, ஸோ தட் இஸ் எலக்ட்ரிக் ஃபியூஸ் will be working in terms of the heating effect of current. And third one, electric furnace. Electric furnace is nothing but the heating element. It will be used to making of steel manufacturing and silicon carbide manufacturing and quartz manufacturing. இதெல்லாம் மேனுஃபேக்சர் பண்ணுறதுக்கு ஒரு பர்டிகுலர் அமௌண்ட் ஆஃப் ஹீட் வேணும். அந்த ஹீட்டை குடிக்கக்கூடிய ஃபர்னஸாக ஆக்ட் ஆகுறது தான் எலக்ட்ரிக் ஃபர்னஸ். Electric furnace will be act as a gas stove to produce the manufacturing of it will be used to manufacturing of silicon carbide, quartz and steel. Okay, so electric furnace maximum use the metal is molybdenum nichrome. It will be used as a molybdenum nichrome. It will be over to the silicon tube க்கு மேல molybdenum nichrome வந்து கோட் பண்ணி வச்சிருப்பாங்க. அது ஹீட் ஆகி அந்த எனர்ஜி வந்து கேரி அவுட் ஆகி சிலிக்கான் இதெல்லாம் நம்ம மேக் பண்ண முடியும். ஓகேவா? ஸோ எலக்ட்ரிக் ஃபர்னஸ் இட் வில் பி ப்ரொடியூஸ்ட் பை த வே ஆஃப் the overcoat of molybdenum nichrome on the silicon tube. It will be giving the nearly is giving the electrical energy is 3000 degrees Celsius. So nearly we giving the heat energy is 3000 degrees Celsius. So electric furnace it will be very much application to create the heat energy to manufacturing the some steels and silicon carbide and quartz. Okay, and fourth one is electric lamp. All are well versed to know the bulb in center one string is there, that the string is tungsten having high melting point, that is 3380 degrees Celsius. So this is the important one word ma. So the melting point of tungsten is 3380 degrees Celsius. Okay, so the tungsten it will be used in the electric lamp. Suppose the current it will be falling highly, the string it will be broken and then not to be glow. Okay, continuously the heat electricity will be applied to the string to be burned and to be giving the glowness of the light. Okay, light ku glowness கொடுக்கக்கூடியது tungsten தான். Tungsten continuously burn ஆகும்போது தான் உங்களுக்கு lamp வந்து glow ஆகும். So the tungsten melting point is 3380 degrees Celsius. Sometimes carbon arc it will be giving the light energy. The carbon arc and some deflectors, that all are it will be act as a electric lamp also. Okay, so that all are the applications of Joule's law. One is electric heater. Electric heaters is made up of nichrome having high melting point and high specific resistance. And then electric fuse. Second application is electric fuse. Electric fuse is two types is there. One is fuse, it's made up of lead and tin. Another one is MCB, miniature circuit breaker. Okay, so sometimes the electric fuse is one time it will be broken, you have to want to be replaced, but MCB is, it will be very much useful than the electric fuse. MCB having it is a miniature circuit breaker. It will be used in various industries and factories and schools. One time the excessive current will be falling, the miniature circuit will be moved down, and then after you have to overcome the faulty, it will be rectify the faulty connection. It will be again it will be used to the again it will be used to in the circuit. Okay, then electric furnace. Electric furnace it will be used to create the electrical energy, and it will be manufacturing the, it will be used to manufacture the steel, silicon and silicon carbide and then quartz. Then it will be having the molybdenum nichrome. Molybdenum nichrome it will be create the heat energy is 3000 degrees Celsius. And then electric lamp. Electric lamp will be having tungsten. The melting point of tungsten is 3380 degrees Celsius. On the applying and the passage of current on the tungsten, it will be continuously burned. It will be giving the electrical it will be giving the glowness. Okay, that all are the applications of Joule's law. Okay, next 3 effects, thermoelectric effects. What are the 3 effects? What's the meaning that thermoelectric effect, ma? Thermoelectric effect, it will be explain the conversion of temperature difference into electricity or electricity into temperature difference. It will be acting vice versa. So it will be explain the conversion of temperature difference into electrical energy and electrical energy into temperature difference. So 3 effects is there: Seebeck effect, Peltier effect and Thomson effect. Seebeck is a scientist. It will be giving the one effect to explain the electricity applied to the two metals. It will be create the temperature difference. That will be explained by Seebeck. Okay, he took 2 dissimilar metals and copper and iron. 2 dissimilar metals. The 2 metals will be fixed. It will be joined at the end of the 2 metals, copper and iron. Okay, 2 metal எடுத்துக்கறாங்க. 2 metalோட end point join பண்ணிட்டாங்க. So one metal it will be dipped, one side of the metal it will be dipped into the coal junction. It will be having one cylinders are having ice cubes. It will be dipped into the one end of the, sorry, it will be dipped into the coal junction. And another one end it will be dipped into the water. The water to be heated by applying heat. Okay, there are 2 junction vachirukanga. One is hot junction, another one is cold junction. So the 2 metals, the end it will be fixed, and then two ends it will be dipped into one cold junction and one is hot junction. So the 2 metals to be form and one couple, that is called thermocouple. The 2 மெட்டலையும் நீங்கள் உள்ளே வச்சுருக்கனால இந்த இடத்துல ஒரு எஃபெக்ட் க்ரியேட் ஆகும், தட் இஸ் thermoelectric effect. One EMF it will be induced, that is thermoelectric EMF. There the 2 sides will be classified as thermocouple. So thermocouple, thermoelectric effect and thermoelectric EMF it will be created. So the 2 electricity will be applied, the temperature difference it will be created, that will be create the EMF, that is called thermoelectric EMF. Okay, thermoelectric EMF it will be depend upon that it will be creating the thermoelectric EMF. It will be completely is based on the nature of the 2 metals. Okay, nature of the 2 metals and temperature of the 2 junctions. Thermocouple oda neenga vechirukeenga, and thermocouple oda 2 junction இருக்கக்கூடிய temperature difference. So the EMF is developed in the circuit will be depend upon the nature of the 2 metals and then temperature difference in the thermocouple. Okay, Then what is Seebeck effect, ma? Taking two dissimilar metals, the two dissimilar metals will be connecting at the end. The two ends it will be dipped into one co-junction and OR junction, and one EMF it will be induced with respect of the temperature difference. The EMF it will be called as thermoelectric EMF, and then that the couple it will be called as thermoelectric couple, and then thermoelectric current it will be created. Two temperature difference it will be create the current, that it will be called as thermoelectric current, and thermoelectric EMF it will be depend upon the nature of the metal and then temperature difference between the two thermocouple. Then what are the advantages of Seebeck effect? Seebeck effect will be used used in the Seebeck generators, electric generators. Electric generators la idu work agudhu, okay, it will be used. The electric generator it will be giving the it will be create the electricity by using the heat energy. So waste heat energy will be converted to the electricity in the generator, Seebeck generator. So Seebeck effect will be used in generators to create the electrical energy by using the waste heat energy. And second one, it will be used in automobiles to increase the fuel efficiency, okay, to increase the fuel efficiency. And third one, it will be used in the temperature difference of two objects. It will be measure the temperature dependence of two objects. It will be used to measure the temperature difference of two objects. So three applications is there. One is it will be used to in the Seebeck generators, that the generator will be create the electricity by using the waste heat energy. Second one will be used in the automobiles to increase the fuel efficiency. And third one, it will be used in the it will be used to measure the temperature difference between the two thermocouples. So Seebeck effect is nothing but two dissimilar metals will create the electric current, that is called thermoelectric current. And second one is Mat.Hr effect. Mat.Hr will be giving one law in the year of 1834. Okay, he took also two metals and to be form a couple A B. The junction, two junction is there, A B. The current it will be applied to the two metals. The current it will be falling from copper to iron. Two metals and the two sides it will be joined. Two junction will be created, A B, and one battery will be connected to the copper string, and the current will be falling from copper to iron. The junction A, the heat it will be absorbed. Heat it will be absorbed. Current it will be falling from copper to iron. The heat it will be absorbed. At the time, the junction it will be cooled. Okay, the heat energy will be reduced. In that heat வந்து absorb ஆகுறனால the heat that the junction it will be cooled. Okay, then the current will be falling from iron to copper. The current it will be falling from copper to iron. Heat it will be absorbed, but the junction to be cooled. The current will be falling iron to copper. The heat it will be evolved. Heat it will be evolved so that the junction to be heated. Heat it will be absorbed, the junction will be cooled. The heat will be evolved, the junction to be heated. Okay, heat absorb பண்ணா the junction வந்து என்ன செய்யும், கூலா தான் ஆகும். Heat வந்து கம்மி பண்றதுனால என்ன ஆகும், the junction it will be cooled. So that the two it will be explained in the by Mat.Hr. And then we have to Seebeck effect also reversible. What is the meaning that reversible? We have to interchange the two junctions. The current will be falling in opposite direction. This is the same way we replace the copper. The current will be we have to mention that we have to change the direction of current flowing from iron to copper or copper to iron. It will be create the temperature difference. It will be opposite, or create the electricity. It will be opposite. So this is also reversible. Seebeck effect also reversible and Mat.Hr effect also reversible. Okay. Next we will go for Thomson effect. Thomson will be giving one effect for the temperature difference to create the electric current. Okay. So first two effects only the wires to be connected, but third effect it will be taking the bar. Okay. First we took copper bar. In center, one heat energy will be applied at the center. Okay, heat energy will be applied at the center. We are taking the copper rod. First the heat it will be absorbed, then at a particular limit the heat it will be evolved. ஒரு இதில் வந்து heat absorb ஆகி அப்புறம் heat வந்து evolved ஆகும். Okay, this is called positive Thomson effect. So copper bar it will be having positive Thomson effect. This is the copper bar. The heat it will be applied at the center of the C. Center C நீங்கள் heat apply பண்ணுறீங்க. A to C the heat it will be absorbed. C to B the heat it will be evolved. Okay. So this is positive Thomson effect. Example for positive Thomson effect is Ag, silver and zinc and cadmium. Silver, zinc and cadmium. This is having the positive Thomson effect. The one word it will be repeatedly asking in the questions, that is which material is having positive Thomson effect, which material having negative Thomson effect. Okay, so positive Thomson effect is copper bar it will be giving the positive Thomson effect, and then silver, zinc, cadmium also is giving the positive Thomson effect. What is the meaning that positive Thomson effect? One time the heat will be absorbed and reach the particular point, the heat it will be evolved, okay, by applying the heat at the bottom. And then second one, you are taking the iron bar. First the heat it will be evolved and reaching the lower point, and next the heating it will be absorbed. So the graph it will be drawn from up to down and down to up. The heat will be evolved and heat will be absorbed. So this is the iron bar will be taking. This is called negative Thomson effect. Some material having the negative Thomson effect, that is platinum, nickel and cobalt and mercury. This all the materials having negative Thomson effect. So positive Thomson effect is zinc, silver and cadmium. Negative Thomson effect, nickel, platinum, cobalt and mercury. The other materials having the negative Thomson effect. So Thomson effect is nothing but one part to be heated, some part the heat will be absorbed, some part the heat will be evolved. Why? Density of the electrons in the metal it will be ஒரு சைடில் டென்சிட்டி வந்து அதிகமாகவும் ஒரு சைடில் டென்சிட்டி வந்து கிரேட்டராகவும் இருந்தால் மட்டும்தான் இந்த மாதிரி ப்ராப்பர்ட்டி வந்து அசைன் ஆகும். ஸோ with respect of the density of the electrons in the material to be heated, sometimes the heat it will be absorbed, sometimes the heat will be evolved. So first heat is absorbed and then heat is evolved, that is positive Thomson effect. First the heat it will be evolved and heat it will be absorbed, that is called negative Thomson effect. So the two effects it will be created in the Thomson effect. Copper bar it will be always giving the positive Thomson effect, iron bar is always giving the negative Thomson effect. These are the three effects. Three effects will be choosing the various materials, will be easily find out the conversion of, easily find out the temperature difference will be create the electricity, or electricity will be create the temperature difference. So three effects will be dealt by Seebeck, Peltier and Thomson effect. Okay, first I already explained that what is heating effect of current, what is heating effect of current, what is Joule's law, what is heating effect of current. We apply the current on the circuit, the resistors drop some voltage, that the voltage will be converted to the heat energy. This is heating effect of current. Second, Joule's law. How to calculate the heating effect of current? According to the Joule's law, the heating effect of current H is equal to I square RT. H is equal to I square RT. So the heat energy, heat will be developed in a circuit, it will be directly proportional to the square of the current, directly proportional to the resistance and directly proportional to the time. Okay, I square RT. And then Joule's law, what are the applications of Joule's law? Electric heaters is completely working on the basis of nichrome wire. It will be having in the electric heaters, it will be convert the heat and electrical energy into heat energy, it will be working. Okay, it is to be worked. And then electric heaters and electric furnace having molybdenum nichrome, it will be covered over on the silicon tube. It will be giving the electrical energy nearly 3000 degrees Celsius. It will be used to manufacture the steel and silicon carbide and then quartz. Okay, that all are to be manufactured by using the molybdenum nichrome. So and then third one is electric fuse. Electric fuse, it will be made up of alloy of lead and tin. And when the excessive current it will be falling on the fuse it will be broken, and then it will be prevent the electronic appliances from the excess amount of current. And various form of fuse it will be used. One is MCB, that is miniature circuit breaker. Miniature circuit breaker will be used in various factories and schools and in some various institutions, because it will be having one knob. Suppose excess amount of current will be carried out to the electronic appliances, just it will be fell down. Then you have to rectify the faulty connection, and then you have to use the MCB. Okay. Then last one is electric lamp. Tungsten will be having the lamp. Tungsten to be burned, it will be giving the light. So current it will be passing on the tungsten to be create the heat energy, and then it will be falling. It will be create the glowness. So tungsten having the melting point 3380 degrees Celsius. Okay. Then various effects: Seebeck effect, Peltier effect, and Thomson effect. Seebeck effect, two dissimilar metals at the ground. Two dissimilar metal, it will be fixed. It will be instead of the two different junctions, and two different junction will be create. It will be induce the EMF, that is called thermoelectric EMF. Thermoelectric EMF, it will be depend upon the nature of the metal and depend upon the temperature difference in the thermocouple. And what are the applications of Seebeck effect? It will be used in generator, it will be used in automobiles, it will be used to measure the temperature difference. And then Peltier effect, Peltier also took the two metals, copper and iron, and the current it will be falling from copper to iron. At the junction of A, heat it will be absorbed, so that the junction to be cooled. At the junction of B, the heat will be evolved, so the junction it will be heated, so that the two junction it will be develop the temperature difference. The current will be falling to the metals, the temperature difference it will be created. That's it will be explained by Peltier in the year of 1834. Okay. And then third one, Thomson effect. Thomson effect it will be classified into two: positive Thomson effect and negative Thomson effect. Thomson took the one bar, the bar to be heated, that the bar it will be giving first the heat it will be absorbed from one point to middle point, and then heat will be evolved middle point to last point. So that is called positive Thomson effect. Negative Thomson effect means heat will be first evolved and heat will be absorbed. So this is the negative Thomson effect. Some example is there. So three effects also reversible. So நீங்கள் கனெக்ஷனை மாற்றி இன்டர்சேஞ்ச் பண்ணும்போதும் அல்ல டெம்பரேச்சர் thermocouple interchange பண்ணாலும் the process it will be reversely it will be working, so that the tree it will be reversible also. So in the today's session we had learned heating effect of current, and then Joule's law, applications of Joule's law, three thermoelectric effects, that is Peltier effect, Seebeck effect, and Thomson effect. And home assignment for today's session. Home assignment. So learn and write the short answer. Learn and write the short answers. Short answers 17 to 21 in your book bag. In book bag. So learn and write the short answer 17 to 21 in book bag. Okay. So okay. Thank you, students.